Use mathematical induction to prove that 9 to the n minus 1 is a multiple of 8 for all n in the natural numbers. We always start with our base case. In this case, our base case is when n is equal to 0 because we're in the natural numbers. 9 to the 0 minus 1 is equal to 9 to the 0 is equal to 1, so that's 1 minus 1, which is 0, which is divisible by 8. So it holds for n equals 0. Now we move on to step 2. Step 2 is when n is equal to k and we make our assumption. We're going to assume that 9 to the power of k minus 1 is a multiple of 8. But it is more useful to write that as 9 to the power of k minus 1 is equal to 8a for some value a in the natural numbers. Step 3, our inductive step when n is equal to k plus 1. What we want to show in this case is that 9 to the power of k plus 1 minus 1 is some multiple of 8, so is equal to 8b for some b in the natural numbers. Starting with our left-hand side, we can use laws of indices to split 9 to the k plus 1 into 9 to the k times 9 to the 1, which is 9 lots of 9 to the k. And now we make our substitution by rearranging our assumption into the form 9 to the power of k equals 8a plus 1. We can then substitute that in and replace the 9 to the k with 8a plus 1. And then minus 1 at the end. Expanding gives us 72a plus 9 minus 1, which is 72a plus 8, which we can factorize to 8 lots of 9a plus 1. But that is of the form 8b, which is our right-hand side. So we've shown that 9 to the k plus 1 minus 1 is a multiple of 8 as long as this is true. We finish with step 4, which is our conclusion. And as always, our conclusion states that by mathematical induction, the statement always holds because it's true when n is equal to 0, and it's also true for n equals k plus 1 if it is true for n equals k.